Okay, so today we're going to be talking about distance. And so you've heard distance, many times in your life. Well, how far do you have to go to get there, etc. And definitely when we talk about distance in math, we often are talking about length as well. And so how you find distance is going to be if you've got like a scale that you're, using, if you have two things at two different locations, you're going to be subtracting to find the distance between both of those things. Okay, so let's look. How far apart is B and D? Okay, and one thing is, yes, you can count. But sometimes it's really hard to count because it's very far away, or maybe it's not really marked, in increments. But what you can do is you write the location of one item, which B is at -1. You write the location of the other one, who is 6, and you put a subtraction sign between them. If you look at this little formula right here, it says location of A and the location of B, and put a subtraction sign between them, and then do the absolute value because we don't want a link to be negative. So we do write down those two locations and add a subtraction sign in the middle. Sometimes there will be minus and negative, but I'm going to highlight this just so you can see it. So this is the first location, this is the second location, and you're going to slap on a subtraction sign between them. And then you're going to do the math, and then you're going to take the opposite value of that answer. Doesn't matter which order you put them in, because the distance, whether you go one way or the other way, is still the same, distance. And so -1 subtract 6 is -7. The opposite value of -7. Opposite value means the distance from 0 on a number line. So if you wanted to find the opposite value of any number, you'd say, how far is it from 0? So if you're standing on any number line at -7, you are literally going to be 7 steps from the origin, okay? So the distance is 7 units. And always label. If it's inches, write inches. If it's units, because I don't give it to you, then that's, you should say units. Okay, the next one would be, what if you do the location of D and the location of B, and then you add your subtraction sign between them? Okay, that's valid. You can do that. And then we're going to take the opposite value. Well, doing the math of that situation is 6 subtracted -1 means 6 plus 1, which is 7. The opposite value of 7 is still 7. So 7 is the distance from those. And if you count and be like, okay, 1, 2 to get the next spot, 3, 4, 5, 6, and then 7. So you take 7 steps to get from B to D. You don't count the location of B. You count how many steps you have to take until you get to D. Okay, so that's another way of thinking about this. Okay. The next thing we're going to talk about would be if you got on a coordinate plane. So if you're looking to find a horizontal or vertical distance, again, we're inching our way smarter and smarter bit by bit. And so if you find -5, 4, so remember when you plot a point, the first part is going to be left and right. And then the second part is up or down, depending if you're going, positive or negatively. So -5, 4 is left 5 and up 4. That's going to be point A. And then -5, -3, this is going to be point B down here. So the question is, how far apart are they? Now you could count. You can also say, okay, that's a vertical dimension. And if you look at these points, okay, yes, there's a bigger formula and I will teach it to you as well. But if you're going vertically, you're trying to figure out, well, what is the distance vertically between the 2 points? Okay, there's no horizontal change, it's only vertical. So if you take the 2 y coordinates and subtract them, and then take the opposite value, then you'll find the distance vertically as well. You'll get the same answer if you count it, but write down both locations. So if you do the 4 and the -3, you have to add a subtraction sign. I know there already is a minus in there. It doesn't matter. You have to add another one. So you write both locations, insert a subtraction sign as well. And then we'll do the math there, and we'll take the opposite value. So 4 subtracted -3 means 4 plus 3, and then the opposite value of that is going to be 7 units. If you count over here, moving, there are 7 steps you got to take if you go from A to B or B to A. Okay, so counting horizontally, that is going to be the change horizontally on the X values. So if you look for these points, point C is 6, 2. That's right here. And then -2 and then 2 as well. If you're trying to find the distance between these 2 points, again, we could count them. There is a bigger formula. It's called the distance formula, and we'll use that mostly with slanted distances. But horizontally, you can simply just subtract the x coordinate if you want to look horizontally, or subtract the y coordinate or count. And so if you do 6 and then -2, you add a subtraction sign, and it becomes 6 plus 2, which is 8. Absolute value of 8 is 8 units. And let's just show. What if you had done it the other way? -2 and 6, and then you add a subtraction sign. The -2 and -6 makes -8. The absolute value of -8 is still 8 units. Okay, it counts out. If you count how many steps it takes to get from one point to the next, then you've got it. Okay. Holler at me if you got more questions. Another thing that we've done is we've looked at right triangles. And so if you see a slanted distance on a graph, the truth is you can drop, like the slope to those things, the rise and the run, and count the squares outside here. So this is 3 units long, and count the squares below it, directly below it, and this is going to be 4. If you want to find the slanted distance, we notice that this is a right triangle. Well, the Pythagorean theorem is true on all the right triangles. A squared plus b squared equals c squared, where a and b have to be the legs, and the legs meet at the right angle, okay? And the C is the hypotenuse, okay? So C is the hypotenuse, the one that's across from the right angle, okay, the longest side. So if we do 3 squared, the one leg's length, plus 4 squared equals the hypotenuse squared. Okay, a squared plus b squared equals c squared. That means 9. And you got to do PEMDAS. In PEMDAS, it says do in the parentheses, then do the exponents, then do the multiplication, then you do adding and subtracting. And so we're going to solve it. 9 and 16. We're going to do adding, it's 25. And then to get rid of the squareds, we square root both sides, and then c is equal to 5. Now, the truth is, it may be a decimal. It may be a radical that you have to break down, and we'll practice doing those. You can use your calculator to take the square root to get the decimal approximation. And then to do the radicals, we're going to be looking for the perfect square root that goes into it. And so we will practice that probably in the back of this. Okay, so looking at this next part, here's a distance from it. It looks terrible, but it really isn't that bad. Okay, you've got to find the horizontal distance. And so to find this horizontal distance here, okay, what you've got to do is got to take your 2 points. So our 2 points, we're trying to find the distance between would be this point here and this point right here. This point here is 1, 2. And this point right here is going to be 5, 5. So if we are trying to find the slanted distance between those 2 points, there's actually a formula that we can use to help us find the distance between these 2 points, 1, 2, and 5, 5. And this is how you do it. The Pythagorean theorem is what you are going to be doing, but it's just a different way where you don't actually have to plot the points. You can actually just do some math to help us find the distance between any 2 points, whether they're slanted or horizontal or vertical. I'm just teaching you a couple methods. This is one that you will need to learn. So if your point 1 is 1, 2, and your other point is 5, 5. Okay, remember at every point you have an X and a Y. Okay, so we're going to start by taking both of the X values. Now, it technically doesn't really matter which order you do them in. You just have to write down both X values and add a subtraction sign between them. With slope, you have to be careful with the order that you do things. But with the distance formula, you just have to put down both the X locations of both points. So 1 and 5, and add a subtraction sign between them. Put a parentheses and a square. And then what you've got to do is take both y coordinates, okay, of the 2 points you're trying to find. So your y coordinates are going to be 5 and 2. Again, it doesn't really matter what order you do them in. You just have to put both y coordinates down in either order. So you've got a 2 and a 5, okay. I'll just do a 2 and a 5, and you have to add a subtraction sign between them because notice the formula has it. Sometimes you'll end up with a minus and negative, don't let that hurt you. And then we've got to do PEMDAS. PEMDAS says do in the parentheses, 1 minus 5 is -4. And then we're going to square it. -4 squared, it is in parentheses. If you don't use a calc, or if you don't use parentheses on a calculator, like just exactly as it's written, it'll give you the wrong answer. -4 times -4 is 16. Your answer should be positive when you square it. So just make sure that you either use parentheses or realize that when you square a negative times a negative, you always get a positive. So 2 subtract 5 is -3. -3 squared is 9, because -3 times -3 is 9. Then we're going to do, it says add these two together, you get 25, and then we're going to take the square root and you get 5 units. So essentially, this formula says if I want to find the horizontal distance between the two x coordinates here, okay, it's 4. Okay, notice they found it. They said it's -4, but it's, enough similar. And then you subtract the two y values right here. Okay, and you get the vertical distance here. And then if you do 4 squared plus 3 squared, or 16 and 9, and then you add them up in square root, you're essentially doing the distance formula without actually thinking about it per se. And so the distance formula kind of just has you subtract the x's, subtract the y's, square both answers, add them together, and then take the square root. And since we know the square is 25, we do it. So let's practice doing the distance formula on this one right here. How you do that is you start by saying, okay, the formula says take both x's, and we're going to say 2, so I don't need to use a pink, but 2 and 8, those are the x's. That's what the formula says. Add a subtraction sign between them, put a parentheses and squared. We're going to take both y's, so 0 and a -3. I'm going to do a 0 and a -3. And remember, the formula has a subtraction sign in it, so you have to add another one there. So we're like, I already see. So what? You got to remember you put both of those values down, the 0 and the -3. Add a subtraction sign between them because that's what the formula has. And then we're going to square it. And then, so 2 subtract 8 is -6, -6 squared. 0 minus -3 is going to be 3 squared. So that'd be 36 plus 9 square rooted is the square root of 45. Okay, so we can do two things. Number one, when we get our calculator out and put the square root, we're going to get about 6.7 units. Okay, so that's one answer. Another one is you talked about this when you were younger, and we're going to review it now, and we're going to kind of build on it all year long and practice it because we'll use it in Algebra 2 as well. If you don't know the square root of a number, square root of 45 isn't something nice. You're looking to say, does it have a square root factor like 4, 9, 16? Those are perfect squares that have square root factors, or that have perfect square roots. And so you can take the square root of 36 and 49 and 64 and 81 and 100. If you don't know the square root of 45, you have to look to say, does one of these here divide into it? Okay. Kind of like when you factored when you were young last year in Algebra 1, you're going to factor this. Are there two things that multiply to make it? One of them being on our list. And this has a square root of 9 times 5. And the square root of 9 is 3. The square root of 5 is still the square root of 5. So your answer is 3 root 5 units as well. And so both of those are valid answers, and you really should do both. Okay, and so we're going to practice doing some breaking down of square roots as well. So let's try doing the distance formula on the next question. Okay, the formula says take both x's. Okay, I'm going to highlight them. Take both x's, and we're going to put a subtraction sign between them. Okay, and so I'm going to erase that. I'm going to do both of these and put a subtraction sign between it. So we're going to have -3 and a 2. Add a subtraction sign between it, parentheses squared. Then we're going to take both y's, place them down. So that's a y, and add a subtraction sign between them. Because that's how you find the distance between any two values, is you write down their locations and you subtract them, okay? And then that would be -5, and then squared is 25. -5 squared is going to be 25. And then you're going to add those up because PEMDAS says do the parentheses, then do the exponents. And then do in this group as well, 25 plus 25 is 50. And we can take the square root on our calculator. The square root of 50 is about 7.1. And then you have to say, okay, the square root of 50 isn't nice, but I spy the square root of 25, it goes into it twice. And so that would be 5 root 2 units. So if there's a square root factor, you should divide it into it and then take that square root. If there isn't a square root factor, well, then you don't break it down. Okay, let's look at the next one. We're going to take both x's and write them down with a subtraction sign between. So we're going to do 4 and -1, add a subtraction sign, square it. Take both y's, 5 and 3, put a subtraction sign between it. Again, we're looking at that formula that's up here, okay? The formula says, I'm trying to zoom in a little bit, put down both x's and add that subtraction sign. I'm going to highlight that subtraction sign. That's this one right here. So both those locations, the 4 and the -1 go there. And then the 5 and the 3 go here. And then you have to add the subtraction sign between those two locations. And then if there's a double negative, great, use it. If there's, you got to follow your adding and subtraction rules. So that would be 5 who gets squared, be 2 who gets squared. So that'd be 25 plus 4. That's a square root of 29. Square root of 29 units is 5.4. But also the square root of 29, none of our perfect squares factor into it, so we can't break it down. So square root of 29 is a valid answer, as well as 5.4, approximately 5.4 units. Okay, let's try this last example with the distance formula. Okay, put down both x's. Okay, let's find it. So both of those x's, again, you can do either order, it doesn't matter. So if you do -3 and then 2, and then put a subtraction sign. Let's put down both y's, 4 and 1, 4 and 1, and add a subtraction sign between it. That would be -5 squared, be 3 squared, 25 plus 9. It's going to be 34. Guess what? Square root of 34 doesn't have a perfect square factor that goes into it. So square root of 34 units. And then if you do the decimal, it'd be about 5.8 units as well. So those are my 2 answers here. Let's look at the last one. It's a little bit of a problem-solving one. It says M, N, O, and P are collinear. Means they're on the same line, okay? And point N is between M and O, and point O is between N and P. Okay, so it means we have M, N, O, and P. If you read it, you're like, okay, that doesn't make sense. Okay, so they tell us that MN is 10, that's yards, and NO is 7 yards, and OP is going to be 14 yards. And the question is, what's the distance from M to P? Well, guess what? Add them up, okay, all the way across, and that would be 31 units. Okay, yards, sorry. Always label as best you can, okay? All right. There you go. Well, thank you so much. I hope you have a great day. Let's see if I can stop this video.